So AI is all the rage right now. Everybody seems to be talking about it. How do you take your models that you've trained and run them at scale? So anybody on the planet can use them. It scales up, scales down. So you don't have to pay a ton when you're not using it, but when you do need it, it's there. How do you do that? Well, I'm here to help. Hi, I'm Matt with Schematical, and in this video, I'll be talking about how I designed some open source scripts that you can use to boot up resources on AWS and host your Pytorch trained models. I started off with Dreambooth, which is a text-to-image type setup, similar to DALL-E, where you can type in what you want to see and it'll generate it. And I'm working to train some models of my own. But I figured, why should I be the only one that can play on this? Let's let everybody do it. So I wired it into Discord, booted up on AWS, and while I was at it, since I consult on scaling things really massively on AWS for companies that do about $500 million a year, some Fortune 5000 companies, figured I would make a video on it and make some scripts that are reusable so my clients can have the benefit of using those as well. And I'm open sourcing them so anybody on the internet can go ahead and have fun. If you get stuck on it, though, please feel free to give me a call. Again, I do run a consulting company that does this. One of the problems that my consulting clients come to me with is they're maybe a more traditionally taught machine learning expert. Maybe they've got a PhD or something like that. And they're really good at training that data and training those models, but they don't know how to take it from, the beefy computers they're running on to the entire internet. How do you scale it? So what typically happens is they go on AWS, they boot up a big, expensive, beefy GPU instance, and they start running it on there. But what happens in the middle of the night when no one's using it? They're still paying for it. It doesn't scale down. What happens if they have a big weekend, a big sale or promotion of their product, they get that press they've been looking for, and all of a sudden they need to stay up and running for 10 times the amount of traffic they're used to or 100 times? How do they scale up? If they did it by booting up the EC2 instance and manually doing it, they'll be sitting there booting up instances all night. And then what happens once that traffic from the big media spike of attention drifts off? What do? You got to start shutting them all down. Wouldn't it be nice if that was all automated? Well, I've done it. It's not a proprietary software I wrote. It's a CloudFormation script. So AWS has this beautiful infrastructure as code, CloudFormation setup. Terraform's another example of it, really nice one as well. But I use CloudFormation for this one. I might do a Terraform one later. For now, let's just stick with CloudFormation. But you can go on and click boot up, and you can boot up your AWS scalable infrastructure that scales right back down. So for this to work, you can't use Fargate, unfortunately. You can't run GPU on Fargate, at least at the point I'm saying this in March of 2023. But you can host your own instances. And there's actually a really cool way you could save money, even more so than what this video has, but I'll get to that later on. For this example, I picked a G4. Let's take a look at what those run us. The smallest one didn't have quite enough RAM for it, so I ended up going with the second smallest one, the G4DN2XL. And that runs us, just if you're doing on demand, 75 cents an hour. Or if you'd like to look at it in months, that is that times 24 times 30 equals $541 a month. So for every instance you've got running, that's how much you're paying for it if you have them always on. So if you want to have 10 of these instances running, $5,000 basically. There are some other tricks I can show you to help scale up and scale down, but for now we're just going to focus on auto scaling. And my CloudFormation scripts already have all that written in. I will be adding more to them later, but let's just focus on that. So that way, when you need it, especially if you're a small startup or if you're just a hobbyist running, some models that you trained on your own, it'll boot up and you're paying that 75 cents an hour. But if you don't, it's literally $0 an hour. Nothing, not a penny. At least for the instance cost. There's like pennies to be spent on network gateways, but we'll deal with that later. And I do mean just pennies. So the first thing you're going to need to do is navigate to github.com/schematical/cf-pytorch-gpu-services. You know what? I'm just going to put a link in the show notes. Right now, you'll notice I'm on feature V1 because I'm in the process of making the video describing this thing. So the video will be in here, but I'll get that cleaned up for you. And this will just basically give you a little overview. What is AWS Batch? AWS Batch lets you queue up as many jobs as you like, and it'll control kind of the computing infrastructure you need to run those jobs. So it'll boot up the servers for you and shut them down. It manages all that auto scaling that saves you so much money and lets you scale up to handle load as needed. CloudFormation, as I think I said earlier, is AWS infrastructure as code. It's all committed in here, so you can take a look at it. We can go through this a little bit more detail later, but if you want to just get started, and I would encourage you to know what you're launching, scroll down to this Launch Stack button. Go ahead and click that. And what we'll do is we'll go through and fill this out. All this information here. You can change up your instance sizes. You can rename it to something cooler. You can change your code build image URI if you want to, or you can just click started. And again, I'm going to go through this more and more detail in a minute, but right now, let's go ahead and get started. Frankfurt. Why did oh God, something went horribly wrong. Why are you booting up in Frankfurt? Okay, we'll fix that. When it's all done, it should look something like this. So you will have a stack, and this is the stack specific to this. Some of these other things are actually part of a larger set of stacks that I am making available, but not important right now. It'll boot up everything you need to run, and it'll go ahead and start building your Docker image. So let's go ahead and just run one of these things so you can have some fun with it, and I'll come back to how this all works. When it's done, you should have job definitions right here, a job queue that's whatever yours is named. I named mine that. And so let's go ahead and submit a job. So and you can do this via command line. You can do this via API. You can do it via SDK. There's all sorts of ways you can do this. I hooked it into Discord, so it does it automatically from Discord, but let's just go ahead and submit one here. Video test, job definition. I'm going to go with the latest one. That should automatically be booted up for you in there. You don't have to actually even do anything. CloudFormation does everything. It's amazing. And we're going to just let it run. Now, the first time you let it run, you're going to want to have it run for a while, because what happens is it needs to cache a bunch of things for this to work. So it downloads the models, etc. After the first run, it should take about a minute, 30 seconds if you're using the same Dreamboot stuff. It depends on your model. But we can work with you on that, help you get that all cached. So the command from the job definition is nothing. Let's fix that. So let's grab this. You can grab that from the Docker file if you want. I'm going to change this to a desert skyline with vultures and I don't know how to cacti, C-A-C-T-A-I, cacti. And this right here is the seed. So if you want to pass it a randomized number so you get different ones, I'll go ahead and do that. I leave it at 8 right now for this. 8 should run one Dream booth set without a problem. Here's my S3 bucket. Again, that's basically a CDN that'll store this, that's secure. This is what was booted up when I ran this in the CloudFormation script. And let's go ahead and send it so you can review all your details right there. You should always know what you're running, but here you go. We'll go ahead and create the job. Now, this particular stack I've already run some stuff on, because otherwise it would take me forever to shoot this YouTube video. But we're looking at about a minute, 30 seconds runtime if it's booted, meaning that there are instances booted up. So let's go ahead and take a look at my instances here. Right now, it doesn't have any instances. This is for an unrelated project. That's for an unrelated project. But in a second, a new one will spawn up. Someday, there we go. G4DN 2X large. Again, running at about 72 cents per hour. But it just started up, and it'll only be alive for probably 5 minutes here. Just for this one, I could submit as many jobs as I want. So if I knew I wanted to just keep one going and save a couple bucks, send a bunch of jobs at it, you can do that. And we can see it's pending down here. Now, as this is initializing, I'm going to click back over to the jobs here. I can look at the job, let's see, the compute environment there. Let's just say I want to take a look at that compute environment. I want to see what we've got available for compute resources. Now, right now, it's switched to desired CPUs up to 8, and automatically does this. You don't have to do anything, just because you created that job, and it's going to try and run it, and we're waiting for that to come online right now. I can see that there goes the instance. All right, it's online. I hopped over to ECS. If you're not familiar with this, I know I'm going very fast. Again, I consult on this stuff. I'll try and do more videos on this stuff. Leave a comment if you want me to go into more detail. I know that some of you guys just want to get this up and running, so I'm moving fast. But now it's up and running there, and we're going to go back to the job and refresh. The job is starting, so that means it's got an instance to run on. It usually goes from submitted to runnable pretty fast, but then you wait for that thing to boot up. So now it's starting. It's next up in line. and we'll be able to see some stuff print off from these logs, but it's going to look like a bunch of gibberish to you. And again, the first time this thing kicks off, it's going to take what seems like forever. But everyone after that should be pretty darn fast. So again, let the first one run maybe 10 minutes. Yeah, probably about 10 minutes, maybe a little longer. And you can watch it because you'll see it installing and building as we start once it kicks off. But again, it takes a minute. So here we're running. Looks like we're sending it. So that it didn't do any installation right there. Everything seems pretty happy. This is just some debug text. And again, you don't have to really know what all this means. But if you want to know, feel free to dig in. Again, code's all open source, so you can look at it. And eventually we'll see it. Actually, you can see our prompt made it through there and everything. I feel like I mixed a C there. C-A-cat. All right, we're going to see what happens there. It's my notoriously bad spelling. All right, it pulled up our model here, which already had been cached from an earlier time. And it's sending it. And this thing should take, now that it's up and running, about 1 minute and 30 seconds, which is typically what happens when I run it on my beefy desktop here. So if you can slim down your Pytorch to run faster, then by all means. And there we go. Now it's running. It's actually sampling, doing however many steps. And we, of course, could beef this up even, bigger instances, but I'm trying to be budget friendly. We could go beefier if we wanted to, multi-GPUs, to the metal here. But, you could see that stuff, $7 an hour for some of these things. You could really start to spend a lot. So I'm trying to avoid that. I'm trying to make this very cost affordable. But you could always add, you could try booting it up on there. Be my guest. Maybe I'll run an experiment doing that. And I bet it'll go a lot faster. So back over to here. Let's take another look. Looks like it's still running here. It's probably doing our 4th image right now. I've got it set up to produce 4 images at a time. And cleanup done. It uploaded it to a test bucket on S3 here. So we're going to go ahead and let's real quick, before we check that, we'll see the job is succeeded. It's done. It took 2 minutes and 15 seconds, which is a little longer than normal. It was cold, maybe because I misspelled cacti. It was struggling. I actually have no idea what we're going to get out of it. So now if we look back at the compute environment, what's going to happen, I'm going to refresh this. And the desired still at 8 right now, but it should actually go down. But we'll come back to that. So here's the S3 bucket that we were using to test with there. There's my horribly misspelled cacti. Let's go ahead and download some of these and take a look at what we got. Again, this is Dream Booth text to image. So we should have, that's pretty cool. It's not the model I was hoping to use for the demo, but that's not bad. Maybe I'll try this again. So it's in a bit of a cartoony format. Nice. That looks cool. That's not the format I wanted to do, so let's try and run another one real quick while we're on here. I'm going to go ahead and clone this job, go video test 2, and again, I should show you how to, I'll try and show you how to do this from command line, but you can definitely do it from AWS CLI. C-A-C, cacti? Let's see. Well, Google knows. Okay, that's what we're going with. Cacti. Now, so I want to give a shout out to Public Prompts. They trained a model called 16-bit scene, and that actually is the model I'm using to kind of play with right now because I haven't trained anything yet. That's the next step in this, but I told myself stop engineering and go make the darn video. So hopefully the training video will come soon after this so we can try and train stuff. But 16-bit scene is kind of a pixel art feature they trained up. So thank you, Public Prompts. I'll try and get a link to your stuff in the show notes. So hopefully this one boots up a little faster. I'm betting because it takes about 60 seconds after the job's done for the compute environment to spin down. I'm betting it's spun down. I know I might have edited fast to make this all look like it was fast, but nope. So it spun down again. We're back down to 0. This instance is going to be terminated, which means I'm not spending a penny on it right now, which is exactly what you want. I will try and play with the load balancing, auto scaling settings, so you can maybe leave it up a little longer. So if people are using it in certain times, we can tweak that. Again, ping me on Discord or hit me up at schematical.com if you need some help with that. But it's a bit beyond the scope of this video. Let's just get it booted up. So now it's in a runnable state. It'll be here for a minute while that next instance boots up. I'm going to try and submit a second job. We're going to watch that go through just as fast because now once you've got it up and running, it'll stay up and running until it's processed all the jobs. So let's clone this job. We're going to go test 3. Let's see, next. A waterfall with fish jumping in it. Let's go ahead and send that. That one's runnable now here. You can see these are the ones that I've just sent up. This one's starting, means the instance has been booted up. We've got the compute power going. So these two should run a little faster. And I realize you guys don't have much context because I'm going to edit the heck out of this. But let's take a look at these dates here. But you can see these two are going to run faster because they're back to back. So if it's high traffic time, you can just keep one going up the whole time. You know what? Let's just send a third one up since this one's still stuck in starting. I'm just going to clone that one right there. Clone job. Test 4. Next. And an Old West ghost town. Sounds good. Great job. So this is when I fire 3 back to back to back. We should see it. It's in a runnable state right away. Let's jump back over here. This one's running. We could follow the logs again, but I'm not going to. Okay, so video test 2 is finished. Now I want you to note that from the time the job was created to the time it was finished, 1754, let's just go 18 to 21. It took about 3 minutes. So that's the boot up time. Let's watch and see if that's faster on this one. Because this one, it's already, as we say, hot, meaning that the instances that it's actually going to run on have been booted up and they are currently running. So you can run back to back to back. If you wanted to run in parallel, I could show you how to do that. It is possible, just costs more money. Basically, all you have to do, well, that second one is running. I'll go ahead and hop over here. All you have to do is edit this and change your maximum CPUs to 16 from 8, because that is based off of the amount of CPUs here. So you could go to 16. You could go to 16 and it would run 2 of them, or you could run this 4XL and it would work as well. But then the minimum size you'd be booting up is this one. So you got a couple of different options there. Pretty easy to work with. You just go to edit the compute environment. You probably should do this in CloudFormation. You can tweak it here, but then it's not as standardized for the next time you go to boot up a stack. So just keep that in mind. And again, you can change your size here as well, but I recommend doing that in CloudFormation instead if given the option. So let's see how the rest of those jobs are running. So this one from the create to boot was 1931. Well, I created it and it sat there waiting for this one to be done. So let's actually look at the end time, 2318 to 2350. So this one took roughly 30 seconds, 32 seconds to boot up there while it was waiting in line. All right, the second one's done. And that's from 2350 to 2524. So about 1 minute, 30 seconds there. That one was 2111 to 2318. So a little about, oh, there we go. Run time's right here. Why am I doing math in my head? 2 minutes and 6 seconds. But again, that was the first one. But it should have everything cached. And now this next one's kicking off. And it should take about another 1 minute and 30 seconds. But it shouldn't take that full 2-3 minute boot up time. And again, we can shrink down that boot up time by already having stuff running and keeping the compute environment minimum CPUs at 8. Then it'll always have something running, but then you're always paying for something. So it's up to you how you want to use this stuff. Do you want to keep something running all the time? You know, what size is it? Or do you just want to have it boot up? And are your customers okay with waiting a couple minutes? I don't know. It depends on your product. Everybody's situation, business, project is a little different. So we can cater it to you. Well, that third job finishes. Let's go and look at some of these things because they're half the fun. And I remember to include the pixel art tag in this one. Let's see the waterfall. Let's take a look. Cool. Pixel arty. Oh, that's a nice one. Little splashes off of it. This one's got like a little Mario block thing going on in the clouds there. I like it. An Old West ghost town. I think this is the final one. So it must be darn near finished. Yeah, that's cool. Let's see if it finished. And the third one did 132. So again, it's a little faster if it's already warmed up. That does not include the startup time for the EC2 instance that has to boot up before this can run. And that's, again, about 3 minutes for that to come into play. So again, if you're scaling up, say you've already got one running all the time constantly, and you know that you're going to have an increase in traffic, it takes about 3 minutes to increase to almost whatever size you want. I don't want to say unlimited scaling, but it can scale. And then that instance is it's running right now, but it should be terminated if I don't submit another job in the next 60 seconds. There it goes. It is shutting down. There we go, shutting down. Now you're going to go back to spending $0 an hour on this project pretty much. So you might wonder what all goes into this. And again, you can jump to the end if you want to, but I'm going to try and quickly explain what is in this CloudFormation script that you're running. And you should always know that because it's kind of crazy to run it without that. In this CloudFormation script right here, like I said, you saw some parameters earlier, like the name, where you want to boot it up at, etc. All this stuff here, those are inputs right there. Then there's the resources. So we're going to go through this pretty quickly. Actually, I can do it in a little bit more detail if I actually show you the graphical interface. So notice this has got an output bucket there. Well, if I go and look at CloudFormation, and I look at the resources tab, you can see I've got an output bucket here, and it's that S3 bucket that we were just looking at those images on, this one here. If I go look at the batch GPU compute environment, I search for that on this page, you can see right there that it is here. And there are several other ones that have that prefix because there's something to do with it. So let's just go through here. So the batch compute environment is what AWS uses to scale up and down for you. The IAM role is a role that gives it permissions to do such things like boot up EC2 instances and so on. The instance profile just basically describes what EC2 instance you're using, the size, and a couple other things there. This actually isn't being used. I don't know why I'm booting it up there. I need to get rid of that. I was using launch templates, but not now. The security group is like the firewall rules. It tells it what it can talk to. It needs that to mount some virtual file drive, which is kind of the magic secret sauce behind a lot of this, how I got it to work. So if you were curious about that, keep following along. The batch job queue is a list basically of jobs that were submitted, and it could go to multiple compute environments if you really want to get fancy. Let's see, we're going to come back to those. So the file system, we use a file system. We're not just using S3 here. So that is where the code is stored for this stuff because it's too darn big to fit on a Docker image. You might have run into that. If you have a Docker image that's over 2 gigs, it's really getting to be a lot. And this all in all is closer to 6 gigs. I actually at one point had it up to 21 gigs. Bad idea. So I am using an elastic file system to mount where the models are stored, where the code is, where the drivers and all the files that aren't like technically on an OS level, and some caches. Those are all in EFS. The job definition is basically the Docker task definition. That has a lot of the information, like how many GPUs you need and all that stuff there. And the IAM role basically says this is what the running task can do and not do. Basically, it says it can push stuff to S3 buckets, specifically the ones I've specified. And then let's look at the build pipeline. So this thing needs to build because you're going to want to tweak it a little bit. And so I have an app pipeline in there that listens right now to GitHub, but I'm probably going to move that to S3 just because that'll make your life a little easier. If you're not familiar with this, you can just push whatever you want to S3 and it'll build it. And then that pushes it to code build. So once it sees a change in there, it pushes it to code build. But because Docker can't mount during a build phase, it doesn't actually finish the build. That's why you got to run it the first time, which takes 10, 20 minutes. And then after that, it's lightning fast, or as fast as you've seen me run it so far. Your security groups, other buckets and stuff like that. And then there's somewhere in here, ECR repository. So if you're not familiar with that, that's basically where the Docker image is stored before it's run. So that's what's inside of this thing. Know this stuff whenever you run CloudFormation scripts or Terraform, because this stuff can cost you money. This stuff is actually running right now. So let's look at what else is in this repository besides that CloudFormation script. In here, there's the buildspec.yaml. So this actually gets run. I need to clean this up a little bit. There's a bunch of stuff commented out because we don't need it anymore. And this basically says, hey, I'm going to get the logins to talk to your ECR. When I build your Docker file, that's where I'm going to store it. And then I'm going to go ahead and save it and tag it and push it and et cetera, et cetera. You don't need that. The Docker file is pretty simple. You'll notice this is very thin. I don't pull down the model here or any of that stuff. I have scripts that do that, again, during the runtime. It's a little dangerous, but being as this isn't like a web server, I'm less worried about it. So, but we go ahead and build. It's actually from this, but if you call Docker too many times from AWS's IP addresses, it gets mad. So this is just that image pushed up to a local thing, but you can just run it from there. We copy over some scripts. We do a bare minimal installation right here. Install AWS right there. Remove some caches that we're actually going to mount some directories there because we want to share that cache between runs so you don't have to re-download that stuff every time. Here's the volumes for the virtual elastic file system that I was talking about. And here's your basic command with a little kind of debug right there. So that's your Docker file, nothing too exciting. I am using Node. Don't hold it against me. Feel free to fork it and run whatever you want. But this Node stuff basically just takes a command in. So just remember that first time you run it, it's got to install some stuff. It manages that logic there. It's a little more complex than I wanted in the bash script. But then eventually runs your Python script there. And I probably could have done this in Python, but Node was just easier at the time. So again, feel free to fork it. Leave a comment if it's something you really want me to do. Then I could probably switch it over there. But that's that. And there's some simple scripts for installing the stuff. If you do, feel free to take these scripts and use them however you like outside of this project. Probably do them in the order I had them in that run thing. But yeah, these scripts are pretty basic and they run that script and copy it to S3. So feel free, be my guest. So that's what's inside of this thing, just so you have some idea. You should always know what you're running. I'm still working on the README. So believe the README. Don't believe what I say in this video because this video is going to be stuck in time. I can't edit the video. I can always edit the README. So make sure you learn, take whatever steps the README stay. That's the more important one. Like this is going away. Goodbye. So let's talk about what is next for this project. One, I'm going to start training some stuff on this. So training Dream Booth stuff, but that's might not be your bag. This can host most stuff Pytorch. We'd have to test that, but feel free to give it a shot. If you find something Pytorch that you find can't run on it easily, leave a message in the comments, jump on the Discord, hit me up, and we'll see what we can do about that. Additionally, besides just training, I am super cheap, and I want to run this even cheaper. So if you don't want to pay the 75 cents an hour it is to run this thing, we can actually use spot instances to bid on GPU usage when it's not super important. And so you can create batch jobs that run at pennies on the dollar, and we should be able to run with that. So that's on my list of things to do. Again, comment if that's, upvote if that's something you're interested in. Let me know. And the other thing that you can do is, I'm assuming a lot of you guys have big, beefy GPUs that are sitting on your desktop. And why shouldn't you be able to host your tasks on there, especially the tasks that are, when you're not critical scale, when you're just, it's nighttime or something there, and the desktop's just sitting there idle. You should be able to host on there and not pay the 75 cents an hour. I'm going to try and get that set up for you too. So that should save you even more money and put your resources that you use every day to train the darn things to use during, to save even more money. So those are three big things that are coming up that are working on. So let me know if you're excited. If this was too crazy and complex, again, I do run a consulting company that consults on this stuff. We make stuff scale very big on AWS. Terabytes of video information coming in, petabytes actually, of video information coming through for IoT projects. We've done, some pretty big stuff for Fortune 5,000 companies, even Fortune 500, but that was a while ago. And, companies that do $500 million in business a year. That's my bag, is to keep that stuff up. So, and AI is the future. So, thanks for jumping on this and joining me as this is my journey to kind of retool and help you guys get the tools you need for ML and AI. So again, if you get stuck, you can jump on schematical.com and we'll try and get you helped out if you want, or jump on the Discord, and we can try and chat there. Just depends on what your needs are. So thank you for following along. I'm excited to continue this series, and I can't wait to tell you more. See you next time. Frankfurt. Why did Oh God, something went horribly wrong. Why are you booting up in Frankfurt? Okay, we'll fix that.